You guys won't have to do a whole lot of notes. So, but if you would do some notes so that you can have it as a background information to study later on, you can get your notebook out.
Are we going to turn these sheets in?
Eventually, you'll turn those in because you'll get credit for doing the activity. So, hold on to them. So, we got this thing called density. And density is equal to mass divided by volume. And so mass represents quantity of matter in an object. And volume is space taken up by an object. Okay, so we have two different definitions. It's nice to know the definitions. Mass, quantity. Quantity would be how many particles are in there. How many of those particles and how dense those particles are. And then second thing we want to relate it to is volume. How much space does those particles take up? How much space they take up. So we know from a little investigation we did, we have solids. You guys don't have to do this part, we've done this already. But you got solids. And then you've got liquids of the same material. We could say the same substance, we heat it up and it becomes liquid. And it takes up a little bit more space. And then we have a gas. And the gas, it takes up the whole container. So gases have not much density because look at volume. Volume is big. Where here, volume is small. Here it's in between. What's the mass of all these? They're the same. Those M's are the same size, which means their quantity and mass is the same. Well, look what's happened to the volume. Now we got little m over this V. This one we got little m over a bigger V. And then this one we got little m over a big V. So you can see why the densities get less as we go from solid, liquid to gas. If this V is big, what does that do to this overall number? Makes it smaller. If this V is small, what's it do to the overall number? It's bigger. Right? So mass over volume is just a relationship. And a lot of times you'll see me when I make comparisons, I'll use a big V that represents a big volume relationship to another V which would represent a smaller volume. So, okay, any questions you have on that? So it's mass over volume. Okay, so you guys don't have to write this down, but when I show you this, you guys are going to use this chart. I'm doing some problems here today. And I'll probably give you 20 minutes to do it. Maybe a little less than 20 minutes. Okay? So this is really important. This grams per milliliter. Or grams per centimeter cubed. That's your conversion. So for example, if I'm using lead, I'm going to either use 11.4 grams over 1 centimeter cubed. Or I'm going to use 1 centimeter cubed over 11.4. I'm going to use one of those two, depending upon what I'm solving for. Okay? Water's pretty dang easy. You're probably not going to get anything wrong even if you do the setup wrong for water because it's 1. Okay? Let's take, for example, ethyl alcohol. Ethyl alcohol is either 0.87 grams over 1 centimeter cubed, or we can say 1 centimeter cubed over 0.87 grams, because all this is like a conversion. that we're using. So you'll have to figure out which one you'll use, and once you do that, it becomes pretty easy to do these problems. Okay? Really easy to do these problems. So I'm going to introduce you to one problem here. Okay, and we'll just okay, so I'm going to do a problem here. And we'll see how this works. Yeah, you can grab one. While I'm writing this up, go ahead and grab one. Okay, so I'll do the first one, kind of show you how to do it. So we're not wanting to know how many centimeters cubed. So we want to know what's a centimeter cube, what's a unit, or what symbol does this centimeter cube represent? D, M, or V? How many think centimeters cubed represents D, density? How many think centimeters cubed represents mass? How many think centimeters cubed equals volume? Volume. Okay? So this is your V. Alright? That's volume. What does this 35.22 grams represent? Mass. Okay? So this represents the mass. Okay? So what we're going to do is we're going to start out this problem, and we're going to go, this is like conversions, we're going to go 35.22 grams of aluminum. Okay? So that's what we're going to start out with. We're going to go ahead and do a setup to where we're going to do like we do in conversions. So what unit should we cancel out? So we're wanting to find volume, or centimeters cubed. What unit do we want to factor out? Grams. So grams of aluminum goes down here. See, that factors out. You guys do factoring, right? So that factors out. What unit goes up above? What I'm trying to find. Centimeters cubed. Okay, now we've got to look at this answer, 2.7. It's either 2.7 grams per centimeter cubed, or we could write it out as 1 centimeter cubed per 2.7 grams. We could write it out either way. Which way do I need to use in this setup? Would it be the one on the left or the one on the right? On the right. So I'm going to put 2.7 down here, and the one up there, and that will give me my answer. Okay? You guys see that this is conversion just like 100 centimeters are equal to a meter. Or there's 1,000 grams in 1 kilogram. You guys did that worksheet, and you had 16 of them to do, and you guys did awesome on setting those up. This isn't any different. This is no different than what you just did. The only thing is, when you do this, you got grams per centimeter cubed, and it's, of course, not metric. So, it'd be 35.22 divided by 2.7. So that would be 13, okay, 0.04. That would be your answer. Does that make sense? Is there any questions you have on this? So all of these, when you set them up, they could be 11.4 grams per 1 centimeter cubed, or they could be 1 centimeter cubed per 11.4, depending upon how you need to set them up. Okay, let me give you one, and let's see if you can do it on your own. It's going to be a little different. Okay, go ahead and figure that out. See if you can solve for that one. I'll come around and check. So get on that last one. You're canceling out your centimeters cubed and you're coming up with grams. And so you either have to have grams on top if you're solving for mass, or you have to have volume on top if you're solving for a volume or centimeters cubed, for example. Okay, so show your work on these problems. I want to see the setups. I want to see your units. The more you do it, the more comfortable you'll be setting these up, solving for them in the future.